All right, seventh graders, as we take a look at today, it's lesson 23, solving equations using algebra. And our target goals for today is that you'll be able to solve equations using algebra. And it shows us the form P of X plus Q equals R, which means P times the quantity, X plus Q equals R, where P, Q, and R are specific rational numbers. Using techniques of making zero, which is by adding the additive inverse and making 1, multiplying by the multiplicative inverse to solve for the variable. You're also going to be able to identify and compare the sequence of operations used to find the solution to an equation algebraically, with the sequence of operations used to solve the equations with tape diagrams, and you'll be able to recognize the steps as being the same. We're going to go ahead, take a look at page 283 in your book. And we're looking at exercise 1, and it's number 1. And it talks about a youth group trip. And it says the youth group is going on a trip to an amusement park in another part of the state. The trip costs each group member of the group $150. That includes the $85 for the hotel, and they get 2 one-day combination entrance and meal plan passes. Our goal here is to write an equation representing the cost of the trip. And we're supposed to let P be the cost of the park pass. So let's go ahead and find our important info. And as we do this, we see that the cost for one member is $150. And we have $85 for the hotel that's included, and they get 2 passes. So think about what we're going to do. How much is each person going to pay? Right, $150. So the $150 is what they pay total. So that is the same thing as they pay $85 for the hotel, plus they get 2 passes. P is the pass. Now remember, our goal is to get P by itself, right? So A just wanted our equation. So now we're going to go to B, and we have to actually solve this. Okay, so as we write this down, we switched this to 85 plus 2p, so we wrote this right side of the equation over on the left equals 150. So we're going to be using those if-then statements from lesson 22. If 85 plus 2p is 150, then we can subtract 85 from both sides because of the subtraction property, okay? What we do to one side, we have to do to the other side. So when we subtract 85 from the left side, we have to subtract it from the right side. On the left side, it is to 0. We still have our 2p. On the right side, 150 minus 85 is 65. So right now, we're at, well, if 0 plus 2p is 65, then 2p is 65. That's the additive identity, meaning that 0 is not going to change what we had, so we don't need it. So if 2p is 65, then we can multiply both sides by 1/2. Notice right now this is a 2 over 1, so that's where we're getting the 1/2. We're multiplying this side by its reciprocal, and that's our multiplication property. And if we're multiplying the left side by 1/2, we're multiplying the right side by 1/2. Notice that doing that is the same thing as if we would divide by 2, which is what we normally do. So if, when we multiplied by 1/2, it all canceled, leaving us 1p. And if we multiplied over here, we have 1/2 times 65, or half of 65, which is 32.5. So P is 32.5. And as we're talking about a price of a ticket, the park pass costs $32.50, not 5 cents. Don't get caught up in that with that decimal. Part B says, model that using a tape diagram now to check. So we need to go ahead and draw a tape diagram. And let's go ahead, and we know that in this, we have $85 for our hotel. And we also know that we get a pass and a pass. And we also know that overall, altogether, it costs $150. So looking at it this way, we can say, well, $150, take away the $85 that we know, equals $65. And then if we take that $65 and divide it by our 2 parking passes, we get our $32.50. So we get the exact same thing. All right, suppose you want to buy your favorite ice cream bar while at the amusement park, and it costs $2.89. If you purchase the ice cream bar and 3 bottles of water and pay with a $10 bill and you get no change, how much did each bottle of water cost? How can we set that up? What would be the equation? Okay, so let's start with that ice cream bar, right? $2.89 plus, what else do you get? 3 bottles of water. What letter are we going to use? How about a W? All right, so we have 3 waters, and altogether that's going to equal $10. Do I have to put my decimal 00? No, I certainly don't. So let's go ahead, and it says solve to determine the cost of 1 bottle, and it also says write the reasons, these justification. We need to get used to the if-then statements. If $2.89 plus 3 waters equals 10, then if we subtract them from both sides, which is our subtraction property of equality, it's doing the opposite. We're adding the opposite. Now, they always show it right after it. We have always done it. We have always written it down below. We write minus 289 and do minus 289. I will still do it this way when I write it because I don't like to write it all out like this. When we do that, we find out that our 289 minus 289 is 0. We still have our 3W, and 10 minus 289 is $7.11. So if 0 plus 3W is 711, then 3W is just equal to 7.11. And if 3W is 7.11, we can multiply both sides by a third. Notice that multiplying by a third, our 3's would cancel, leaving me just a W. On this side, nothing cancels, and remember that 7.11 is actually over 1. So you would really multiply across and divide by 3. So as we do that, we have just the W on the left, and 7.11 divided by 3 is 2.37. So therefore, W, each water, is $2.37. Now it says we're going to multiply using a tape diagram, or model using a tape diagram, model. So what did we have? Well, our tape diagram, we have 4 things. The first thing we had was our $2.89 ice cream. We know the total cost was $10. And we have 3 what? Yeah, waters. So there's our 3 waters. So when we put this together now, we can just say $10, take away the ice cream, equaled $7.11. So we know that these three W's together, we just have to divide it by 3 to find out how much each water was. And again, we got $2.37, so it did match. Number 2, weekly allowance. Charlotte receives a weekly allowance from her parents. She spent half of this week's allowance at the movies. That's a very important piece of info, right? Half at the movies. But earned an additional $4 for performing extra chores. If she didn't spend any additional money and finished the week with $12, what is Charlotte's weekly allowance? We're going to write an equation that can be used to find the original amount of Charlotte's allowance. Let A be the value of her original weekly allowance. So let's take a look at it. Let's start with, look at the first part of it. Half of her allowance. She spent half of her allowance, but she earned even more. So how do you write that she earned an additional 4? You got it. We're going to add that 4 on there, right? If she didn't spend any additional money and finishes with 12, what do we need to write next? Yes, equals $12. So this is what she spent. This is what she still has, or that she earned extra, and this is where she ended her week. So now we're going to have to solve that. So if we write, let's do this. There we go. Half of her allowance plus $4 equals 12. Remember, our goal is to get that A by itself. So we're going to subtract 4 from both sides. And we're doing that because we're adding the inverse. Okay, we're adding the inverse. We're doing the opposite, adding the opposite inverse. So now we have 1/2 A is left. This would be a plus 0, and 12 minus 4, is 8. Now, we can get rid of this 0, right? So we know if that's true, then we could actually write 1/2 of A equals 0 because of the identity property. Okay, that 0 isn't going to change anything. Now, how do I get rid of this? Well, we know that a half is being multiplied by A, right? They're next to each other. So really, we would be dividing by a half, and then we would have to divide this side by a half. But rather than dividing by a fraction, remember to divide by a fraction, here's the tip. What do? Keep, change, flip, right? So we're going to keep this, we're going to change it to multiply, and we're going to flip it. So if we were going to do that, notice all of these cancel, just leaves us ones everywhere, which is just an A. If we multiply this left side by 2/1, we have to multiply the right side by 2/1. And when we do that, 8 times 2 is 16. So the original allowance is $16. Now, Charlotte's goal is to save $100 for her beach trip at the end of the summer. Use the amount of weekly allowance you found in Part C, which we have 16, right, to write an equation to determine the number of weeks that she must work to meet her goal. So what are we going to write? Well, she needs 100, and she gets 16 every week, right? So $16 every week equals 100. And actually, it told us, that we had to use W. So 16W. What are we going to do to get the W by itself? They multiplied by 1/16 because it was 16/1, so they multiplied by the reciprocal, which is the same thing as dividing by 16 on both sides. Because right over here, we're still going to end up getting 100 divided by 16. When you do that, we get a W equals 6.25. Now, my question for you is, it says in your answer to part D, and based on the story above, do you think it'll take Charlotte that many weeks? Do you think it will take, I think we're missing a word. And based on the story above, do you think it'll take Charlotte that many weeks to meet her goal? Why or why not? Can she get her goal? Okay, that's the essential. How many weeks is it actually going to take her? No, not 6, because look, it's more than 6. We need part of that next week. So how many weeks is it really going to take? It's going to take her 7 weeks. 7 weeks. And she has till the end of the summer to have that money. Is that correct? So how many weeks are there in the summer? How many are you thinking? Does she have 7 weeks in the summer? Absolutely, because 8 weeks is 2 months, right? So she will have enough, if she doesn't spend stuff, right? Have enough because the summer is more than 7 weeks. Perfect. Okay. All right, we're going to go ahead and stop here, head back to the classroom.